Okay, welcome back. So this time I'll have a look at this particular integral, and in this case, what's the substitution that we can make for this one? So we've got 2 sin x cos x. Is there 2 sin x cos x that we can use? Well, look up here. 2 sin x cos x can be immediately substituted for sin 2x. Well, that's great. That just means that we can just make the substitution straight away. How good is that? We don't even have to change anything. That's fantastic. Okay, and what we'll know from our integration is using a u substitution. A u substitution of sine is going to get us minus cos 2x divided by 2, or a half. I'll leave you to work that out now. You should be capable of managing this step. Okay. It's very important to me that you're able to do that. Okay. That was pi on 4. Little modification there. So between pi and pi on 4. So just being able to do that is now required to go into Math 1. So we put our scaffolding in, and we're going to dump pi on 4 in there. Pi in there. So we're going to have minus cos 2 pi on 4 over 2 minus cos 2 pi over 4 2 pi over 2. Okay, so cos 2 pi is the x, so that's 1. So it's minus a half. This first term is minus a half. Now this cancels. So we get 2 cos pi on 2, which is halfway up. That's this one. Cos term is 0. So it doesn't matter about minus 0 over 2. Minus 0 over 2 is still doesn't matter. So the answer is minus a half. Typically units squared, shouldn't I? Okay, so we're able to generate that one as well. All right, now we've got some substitutions that we need to do. So these are always a fair bit of fun. So if we do sine 90, so this is now just a bit of fun. This is not something I want you to fret over, but it is something that can come in useful, but it's not overemphasised. Okay, which is sine 2 lots of alpha to be 45. So this is this one up here. So we got that one there, sine 2 lots of 45 is 2 sine 45 cos 45. 2 sine 45 by substitution. And guess what? Exact value is trig. Now, what is sine 45? 45, they're the same angle, aren't they? They're the same angle. So it's 1 on root 2. It happens to be the same thing. So this is equal to 2 lots, 1 over root 2, and we're just writing them squared, okay, which will be 2 times. Now remember the power, that's a half, isn't it? Half times 2 is 1, so it'll be 2 times a half, and 2 times a half is 2 over 2, which is 1. That's your final. So it's just a bit of expression. Okay, you just go back to your tables and see what you can find, and you can work it out from there. Okay. So if we look up at our cos 2 squared, 2 cos 2 alpha, and cos 2 alpha we can see is 3 options. Cos squared minus sine squared would be a good fit. Or 2 sine so I think it's one of these. Cos squared. Or cos squared sine squared. So it's this one, cos 2 alpha, where 3x is alpha, so it's just going to be cos 6x on substitution. That's fine. 2 lots of 3x. Okay, 2 lots of 3x. For any angle in the second quadrant, sine angle equals 3/5. Find cos and sine 2 theta. So in effect, what we want to do here is think about drawing up some pre-work. We're going to have to do some pre-work. Now, sine 2 theta, if we do this one down here, just put a line on that one to mark it off. Sine 2 theta, there it is. It's equal to one of the substitutions, sine theta, cos theta. Very straightforward. Okay, so how do we use that in our version? Alright, so we're told sine opposite over hypotenuse is equal to 3 on 5. So this means that we've got a Y5 triangle of opposite 3, 5. Now we can work out x by using Pythagoras, but as it's a right angle triangle, x is 4. I'm going to let you work Pythagoras out and disprove that. It's a 3, 4, 5 triangle. Okay? So cos theta, now it says in the second quadrant, so in the second quadrant we have negative x and positive y. So that means sine will be positive, which it is, and we're to find cos and sine 2 theta. So cos theta be equal to adjacent over hypotenuse. So there are two pieces of information for that. So we found cos theta. So that's fairly straightforward. Remembering that x is negative. So we're going to put a negative 4/5 there. It's negative in the second quadrant. Okay, so negative 4/5. 3/5. All right, the next thing we want to consider is doing the solution for this. So that will be 2 times 3/5 times minus 4/5. So all of that multiplied out will be minus something on 25. And something on 25 is 2, 3, 6, 4, 24. So we've been able to find the double angle result as well. Okay, well that's working out for us quite well. All right, we're going to move on to solving particular equations. So let's have a look at a couple of those. Now they're not as difficult or dramatic as you think. Just if you've been doing your white sheet, there's no problem here. So let's do a bit of undo. Minus Wrk1. What you do to one side, you do to the other. So 2 cos x becomes 2 cos x equal minus Wrk1. Undo. What you do to one side, you do to the other. Okay, so this one's asking us, now our association, our proportion, and our sign. So we've got association, proportion, and sign. So when we look at our, where's x? So what is it? X long negative. A long negative x is here. A long negative x is here. Okay? So that means it's got a short positive y or a short negative y. So our base angle theta is 30 degrees, which is bigger. The smaller angle has the bigger denominator. Now we know we can count 1, 2, 3, 4, 5, 6, 7. So count them around. The two angles will be 1, 2, 3, 4, 5. 5 lots of pi on 6. And 7 lots of pi on 6. 7 lots of pi on 6. 7 lots of pi on 6. So therefore, x is equal to 5 times x. Or 7 times x. 5 lots of pi and 57. So if you put in cos those two angles, you'll get minus root 3 on 2. So let's just check that. So let's just check what that means. So let's just put it in the memory. We'll change that to radians. So we go 3, the square root divided by 2 is equal to minus 0.866. So we'll just put that in the memory. Alright, so what we want to do is take the cos of 5 pi on 6. 5 times pi is equal to, divided by 6 is equal to, now we'll take the cos of that. It's the same one. Minus, remember equal, there will be no change. Watch this. No change. 0.866. So it's the same. What about 7 pi on 6? 7 times pi is equal to, divided by 6 is equal to trig function cos minus 0.866. So what it's showing us is that the x value has two triangles with it, a positive y, that's this one, and a negative y, that's this one. Both of those have a negative x of minus root 3 on 2, given by the triangle minus root 3 on 2, half 1. Exact values trig. Okay, we've got to do it, and do it, and do it, and do it. Alright, I'm going to leave it there, and I'll be back with the next one in the next video.